Good afternoon. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. I'm your host, Leon Jones. And if you saw my first video I did on this two-part series, Algebra and Trigonometry, you're going to like this second video because I'm doing part two of two. Now, I told you algebra was very important because if you can't do algebra, you're not going to be able to do advanced mathematics like differential equations, linear algebra, calculus, and there's sciences that involve algebra as well, and social sciences like economics. Of course, there's physics, there's chemistry, and even biology. Now, that being said, the reason why I'm doing a two-part series is because before you can move on to pre-calculus, and that's in between calculus and trigonometry, you also have to understand trigonometry. Now, when we deal with trigonometry, we're basically dealing with triangles. Now, trigonometry, from Greek trigonon, which trigonon is a triangle. Triangle has three sides. And metron means measure. So we're basically measuring lengths of triangles, and we're also measuring or we're taking angles. Now, trigonometry is a branch of mathematics that studies relationships between the side lengths and angles of triangles. Now, the word trigonometry, or the field, basically emerged in the Hellenistic world during the 3rd century BC from applications of geometry to astronomical studies. Now, Greeks focused on the calculation of chords, while mathematicians in India created the earliest known tables of values for trigonometric ratios, also called trigonometric functions or trigonometric functions. And the trigonometric functions that you see that are common to trigonometry are sine, cosine, and tangent. Now, when I took trigonometry, we used a made-up word called SOHCAHTOA. Now, what is SOHCAHTOA? When we talk about SOHCAHTOA, sine, that's what S. The O means opposite over hypotenuse. When we dealt with cosine, it's adjacent over hypotenuse. And when we dealt with tangent, tangent is, of course, opposite over adjacent. Now, throughout history, trigonometry has been applied in areas such as geodesy, surveying, celestial mechanics, and navigation. Now, I've been out in the field as a surveyor, and when you're setting brick points for a house, you're utilizing angles. And just like algebra, sometimes you're going to be given a triangle where you're going to have two sides in an angle, and one of the sides is going to be unknown. So you're going to have to use a theorem known as Pythagorean Theorem, or you'll have to use the law of sines or the law of cosines. Now, trigonometry, when you get to calculus 2, is known for many identities. Now, these trigonometric identities are common, and they're commonly used for rewriting trigonometrical expressions with the aim to simplify an expression, to find a more useful form of an expression to solve an equation. Now, when we talk about trigonometric ratios again, I just mentioned we're dealing with sine, cosine, and tangent. Now, when we talk about a right triangle in trigonometry, we talk about the adjacent side, the opposite side, and the hypotenuse. Now, the hypotenuse is the longest side of the triangle. Now, just like algebra, there are also reciprocals. Like in algebra, the reciprocal of A is 1 over A. The reciprocal of 2 is 1/2. The same applies in trigonometry to the trigonometric functions. Now, just like I said in algebra, if you cannot pass trigonometry, you're not going to be able to solve problems in statics. Now, if you don't know what statics is, basically when something is static, it's at rest. And when you deal with statics, you're going to deal with forces. How much force is coming down on a beam? You're going to have to find your moments about a certain point. And if you don't understand area, because part of a triangle, when we deal with an area, you deal with area equals 1/2 base times height. If you're dealing with, let's say, a trapezoid, you can also apply trig. You want to break everything up into triangles and, of course, rectangles. Of course, rectangle is basically side equals length times width. Now, as an inspector, if you're doing quantities, you're going to use a lot of trigonometry. You're even going to use circles like pi and 2 pi. But going back to reciprocals, when we talk about reciprocals, like cosecant, when I said opposite over hypotenuse for sine, when we deal with the cosecant, we deal with the hypotenuse over the opposite, which the cosecant equals 1 over the sine. So 1 over the sine is the reciprocal to the cosecant. Now, when we deal with the secant, we talked about the cosine when we dealt with the adjacent over hypotenuse. Well, let's flip it and talk about the reciprocal of sine, which is hypotenuse over adjacent, which the secant is 1 over the cosine. Now, when we talk about tangent, we said opposite over adjacent. Well, when we deal with the reciprocal of the tangent, it's called the cotangent. The cotangent, of course, is the adjacent over the opposite, or sine over cosine also equals the tangent, so cosine over sine would equal the cotangent. Now, when we talk about the unit circle, trigonometric functions can also be used to represent the unit circle. Now, the unit circle is a circle of radius 1 centered about the origin in a plane. Now, in this setting, the terminal side of an angle A is basically placed in a standard position that will intersect the unit circle at a point x comma y, where x equals cosine A and y equals sine B. Now, this representation allows for the calculation of commonly found trigonometric values, such as those that you may have heard of, like a function. You may have 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Now, the reason why those are important, because if you're dealing with electrical engineering, you're going to have a sine wave. Now, sine wave is, you're going to go from 0 to pi, down to negative pi, on up again to 2 pi, down to minus 2 pi. And also, when we deal with simple harmonic motion, you're going to have phase shifts or cycles. Now, when you deal with sine, cosine, and tangent, you're always going to have graphical functions. Again, the range for the sine on a graph is usually -1 to 1. Same with cosine. Now, when we get to the tangent, it's negative infinity over infinity. Why? Because when we talk about the tangent, basically, it's a bunch of lines. If you draw a line down the middle, for the most part, you're going to have a squiggly line. And these tangents, these cosines, and these sines are graphed based on the equations. Now, some may look like parabolas, some may look like, again, squiggly lines. But when we deal with trigonometry, one must understand that we're utilizing a number of equations. Of course, we have the identities. We also have circles, rectangles, triangles. We're trying to find the angles. But trigonometry is encompassed with 3 different functions for the most part, and 3 different inverse functions. You have sine, cosine, and tangent, cosecant, secant, and cotangent. If you understand those terms in trigonometry, if you understand that trigonometry is about measuring triangles. Now, I didn't say right triangles, because we do have a Greek theorem. If you want to do right triangles, it's called Pythagorean Theorem. But you also have the law of tangents. You have the area. You have the law of sines. But the big one is the Pythagorean Theorem. Now, what is the Pythagorean Theorem? Well, basically, it's known as a squared plus b squared equals c squared. And the way you get c squared is you total a squared plus b squared together to get c squared, and then you take the square root of c squared to get c. Now, that formula, believe it or not, is very important. Why? Because when we deal with identities, such as getting 1 from sine and cosine, because you're going to see this in calculus. If you want to get 1, then you're going to have to take the sine squared plus the cosine squared, and that gives you 1. Now, to get your secant squared, you could take your tangent squared plus 1 to get your secant squared. Now, one must remember that secant, because if you want to do identities in trig, you want to break everything down into 2 major components. Guess what that is? Sine and cosine. Why? Because I can go ahead and multiply sine and cosine, and I can cancel out sines and cosines. A number of individuals, when they see tangent, they get confused. You must remember that tangent is sine over cosine, and cotangent is cosine over sine. Secant is 1 over cosine. Cosecant is 1 over sine. Now, you also have other formulas like Euler's formula. Now, Euler's formula is E, which is 2.718. We call that a term that is close to the imaginary unit of I. I equals negative square root of 1. Now, you're not going to see too many E's and I's until you get to differential equations or you get into complex numbers. That's when you're going to use I. And that all comes from trigonometry. This is what I'm telling you. If you cannot pass trigonometry or understand trigonometry, you're not going to be able to go on to higher maths, because when it comes to the order of mathematics in college, you're going to start off with a placement test. So the placement test is going to see if you're ready for trigonometry and college algebra. And then from there, you go on to pre-calculus, then calculus 1, calculus 2, calculus 3, differential equations, statistics, and then linear algebra if you're going to be an engineer. Now, it's very important that you understand trigonometry as well as algebra, because every math is going to involve trigonometry and algebra. And some of your sciences are going to involve trigonometry and algebra, like electricity. You're going to deal with cycles. You're going to deal with imaginary numbers. You're going to deal with the sine wave, statics, dynamics, when you're going to find your angular velocity. You're going to talk about collisions, elastic collisions and inelastic collisions in physics. So you need to understand kinetic energy and potential energy. These are all going to come from algebra and trigonometry. More circle, where you use stresses and strains. And that comes in soil mechanics. That also comes in strength of materials. So you see where I'm going? Once you understand algebra and trig, it's going to be much easier for you to go on to do higher maths. And why do I say that? Because no matter how complex the math is going to be, everything is always simplified through college algebra and trig. Or I'm going to say algebra and trig, because there's no difference between high school algebra and college algebra, except for the names. Trigonometry is the same. But when we talk about trigonometry, it comes from the Greek word trigonon, which means triangle, and metron, which means measure. And what you're doing is measuring sides of triangles. Or we can say trigonometry is a branch of mathematics that studies relationships between side lengths and angles of triangles. And that is the conclusion of today's lesson on trigonometry. If you like what I just presented, please comment, share, and subscribe. Now, if you're looking for some controversial content on a lighter side, check out the 401 Talk Zone radio show on YouTube. If you want more controversial topics, and I'm also going to put some STEM subjects on as well, check out the 401 Talk Zone radio show on Blog Talk Radio. 215-383-5785 is the number to call in. And if you can't find me on YouTube or Blog Talk Radio, check me out on Twitter, MeWe, and Parler. And once again, I thank you for listening to this edition of the Mind of STEM channel. And on this channel, get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. Please have a wonderful and gracious day.